I'll just illustrate one example. So you have this math speak here, all of this math garble, and really it's just a way of pointing out asymptotes. And I know that it is because we're dealing with limits and we're dealing with infinity and we're dealing with numbers. So if you look at the first statement, the limit as x approaches infinity of f of x is equal to 2, that's nothing more than a statement saying that we have a horizontal asymptote at y is equal to 2 as x approaches infinity. For the next statement, we know we have a horizontal asymptote at y is negative 3. So as x approaches negative infinity, we know we're going to get very close to this line. The last two statements tell me that I have a vertical asymptote, right, because x is approaching some number, and we know our output is approaching infinity. So I know that when x is equal to 1, we're going to have a vertical asymptote. And I know as x approaches 1 from the right, so coming in from the right-hand direction, we're going to be going up. Coming in from the left-hand direction, we're going to go down. And that's all we know. So now we just need to sort of fill in what's going on with our vertical asymptote. So going to the right, I'm going to get close to 2. Incidentally, I am allowed to cross over vertical asymptotes. I could do something like this, for all I know. As x approaches, say, negative 3, I might cross over this infinitely many times. But the whole deal, again, with the horizontal asymptote is that we are able to create some little band. And again, it doesn't matter how wide it is. We can choose it as infinitely skinny as we like. But at a certain point, our function is going to enter within that band, and it will never, ever leave. Same thing going to the right. And that's one good example that you can use on your homework.